I know that your theme is embracing uncertainties, and it's very appropriate for this particular year. My title is Pandemic Certainties in an Uncertain World. Now, there are two big questions that frame this. First of all, why were we so unready for this pandemic and so unable to contain it? And secondly, as Dr. Tedros said, how can we be better prepared when the next pandemic comes? Now, I'll circle back to those two big framing questions, but first I want to present to you eight certainties in this very uncertain year. 8 certainties about the pandemic, and each of those certainties is accompanied by an uncertainty. I'll run through them very quickly, these 8 certainties. First of all, there was a certainty that a pandemic was coming, a next big pandemic. But we were uncertain when. When would it come? Secondly, there was a certainty that it would be caused by a new virus, unknown to science, unseen in humans before. But what kind of virus? That was uncertain. Third, we could be fairly certain that it would be a virus of a particular sort. There is a group of viruses called the single-stranded RNA viruses. It contains a number of different kinds of viruses, this group, a number of different families of viruses, the influenzas, the coronaviruses. We could be almost certain that the new virus would come from this particular group, but we were uncertain which group it would come from, which family of viruses, which particular kind of viruses. Fourth, we were certain that this new virus would come from a wild animal, and I'll explain why. But we were uncertain what that wild animal would be, which wild animal. Fifth certainty, we knew that this virus would follow the 3 Darwinian imperatives of evolution, the 3 Darwinian imperatives of our evolution that allow any creature to evolve and succeed. But we didn't know whether we could prevent it from succeeding or how it would succeed. Number 6, we could be certain that this virus would evolve. It would evolve, but would it evolve to become more dangerous to us, less dangerous, more transmissible, less transmissible, more lethal, less lethal? That has been uncertain. 7th certainty, this virus will be with us forever. Now that it's in the population, we can feel certain that this virus is not going away. But uncertain, will it be with us as a nuisance, like the common cold viruses, some of which are caused by coronaviruses of other sorts? Or will it be with us as a scourge that continues to kill, if not millions of people, tens of thousands of people, even hundreds of thousands of people per year? That is uncertain. And finally, we can be certain that this is not the last pandemic threat that we will face. There will be more. But uncertain, what will the next one look like? When will it come? We don't know. Now let me go back and explain a little bit about each of these certainties and uncertainties. First of all, we were certain that a pandemic was coming. 10 years ago, when I was researching my book Spillover, I talked to a number of disease scientists, infectious disease scientists, and I asked them this question: will there be a next big one, a next pandemic, a global infectious disease that sweeps around the world and kills a great number of people? And these disease scientists told me that yes, there would be the next big one. It was coming. We couldn't say when, we couldn't say whether it would be in 3 years, 5 years, 10 years, but yes, they told me it was coming. And so I put that into my book. Not because I was prescient, not because I was a prophet, I was not. I was merely listening to what the scientists, the disease scientists, were saying 10 years ago, and they've continued to say this. They also told me that this new pandemic would be caused by a new form of virus. A new form of virus. What kind of virus? Well, as I said, a particular group of viruses were at the top of the watch list. The single-stranded RNA viruses. Now, it doesn't matter what technically this means, except that single-stranded RNA viruses have a genome. Their genetic material is a single molecule, not a double helix of DNA, which is stable, but a single long molecule of RNA, which is a related genetic molecule. And what's significant about this is that those viruses mutate more, they change more. When they copy themselves, they make mistakes in their genome. Those mistakes are mutations, and those mistakes make the virus unpredictable and able to evolve relatively quickly. So 10 years ago, the scientists were saying to me, yes, look out for a single-stranded RNA virus. Now, what does that mean? It means a particular group of families of viruses. It means it might be the influenzas, which are single-stranded RNA viruses. It might be the paramyxoviruses, never mind what that family name means, but that's a group that includes measles, among others, and some other dangerous viruses that have the capacity to evolve quickly, to jump from one kind of host into another. Coronaviruses were at the top of the list also. They are single-stranded RNA viruses. So 10 years ago, scientists were telling me, beware of a new coronavirus. And they were telling the world, these scientists, but the world mostly did not listen. They also said, this virus will come from a wild animal. Why did they know that? Well, they know that because every virus must come from a host of some sort. It must come from a complex creature. It must come from a form of animal, plant, fungi, or even bacteria. These are all cellular creatures. Their bodies are composed of complex cells in which there is a complex metabolism that allows for creatures to replicate their genomes, their DNA. A virus is not a cell. A virus is just a capsule containing a genome. It cannot replicate itself, it cannot multiply unless it is inside the cell of a more complex creature, an animal, a plant, a fungus, or a bacteria. So that's where viruses come from. We live in a world of viruses. There are an untold number of viruses living in the animals, plants, fungi, bacteria of our rich, diverse ecosystems. They are there. Some scientists estimate that there might be as many as 320,000 different kinds of viruses just living in mammals. And the viruses that live in mammals are the most likely to be able to infect humans. When that happens, when a virus passes from a non-human animal into a human host and takes hold and replicates and becomes a human infecting virus, that moment is called spillover. And that's why I titled my book in English, Spillover. That's the moment. A virus doesn't climb into us from non-human animals. It spills into us. A virus has no intentions, no will. It can't run, it can't walk, it can't swim, it can't fly. It rides a virus. So a virus spills over from a non-human animal into a human. We could predict or we could guess with some confidence that when a new virus hit us that became a pandemic, it would come from a wild animal of a certain, probably of a certain type. It might come from a bat because many viruses have come to us from bats. Now, bats are important creatures. They're beautiful creatures. They perform functions in ecosystems, but they also happen to be very diverse. There are many, many species of bat, and therefore there are many, many species of viruses living in bats. So some spill into us. Or it might come from a primate, a monkey, a chimpanzee, something closely related to us evolutionarily. Or it might come from a rodent. We didn't know. Now we know that this virus probably did come originally from a bat. We knew that this virus would obey the three Darwinian imperatives. What are the three Darwinian imperatives that guide evolution? First of all, any creature that reproduces with a genome, copies itself with genetic material, is subject to the Darwinian imperatives. It's part of the evolutionary process, and that includes viruses. Viruses can evolve. Now, what are the Darwinian imperatives? First of all, copy yourself as abundantly as possible. Make as many offspring as you can, as fast as you can. That's the first Darwinian imperative. The second Darwinian imperative is expand yourself in geographical space. Go everywhere. Fill habitat. Colonize new places. The third Darwinian imperative is extend yourself in time. Extend yourself in time and therefore avoid going extinct. Now, you extend yourself in time by doing those first two things that are Darwinian imperatives. You multiply yourself in as many copies as possible, and you expand yourself in geographical space. That allows you the likelihood that you will extend yourself in time. If you do those things, you will evolve and you will survive. You will succeed in Darwinian terms. And this virus, the virus that causes COVID-19, the virus the scientists call SARS-CoV-2, has succeeded beautifully so far. It has spread itself across the world. It has multiplied itself abundantly. And therefore, there is a likelihood that it will succeed in terms of time. It will avoid extinction. It will be with us forever, as I said. Certainty number 7. We will soon have many people vaccinated. Scientists have worked very hard and brilliantly to produce vaccines. The vaccines are now being put into people's arms. They are being disseminated, and that will help us. That will get us past the pandemic phase of this virus, this new virus, SARS-CoV-2. We will get through this. We will pass through the pandemic. Life will go back to something like normal. But will this virus be gone? No, no. The scientists that I trust say that no, this virus will never be gone now that it's in the human population. It will be with us. Remember the measles virus. The measles virus has been with us for thousands of years. It is still with us. We have had a vaccine for measles for more than 50 years. Measles, some people take it for granted. They think, oh, it's not an important disease anymore. It's a childhood disease. But measles killed more than 200,000 people in 2019. Measles killed 200,000 people in 2019, despite the fact that we've had a vaccine. Now, that is one suggestion of what COVID-19, that disease, may be like. The virus may be with us 30 years from now, 40 years from now. I suspect that children will still be vaccinated against COVID-19, and there will still be flare-ups. But we can control it. We can control it. It will no longer be an emergency. It will be a chronic but serious problem that we have to deal with continuing vaccination. And finally, will this be the last pandemic threat? Once we've dealt with COVID-19, can we forget about this problem, the threat of pandemic diseases? No, we can't. We have a certainty that there will be more. When we get this pandemic under control, we should celebrate for 5 minutes and then start planning for the next. There will be another one, and we don't know. Will it come in, the next one come in 3 years? Will it come in 5 years? We don't know. We can only be sure that there will come another pandemic threat, another dangerous new virus coming out of wild animals, getting into humans. Now, there are 4 stages of threat. I've mentioned spillover. That's when a virus passes from its non-human host into its first human victim, replicates, and makes that person sick. Then, if it's successful in transmitting, and transmits from one person to another and causes a dozen, 2 dozen, 3 dozen cases in a remote village somewhere in Africa or Italy or the southwestern United States or Chile, that is an outbreak. If the outbreak expands across a country, spreading from one person to another, infecting hundreds, thousands of people, that's an epidemic. If it gets to the airports and spreads further, spreads from one country to another, spreads across the world, that is a pandemic. So this is what's important. There will be further spillovers of dangerous new viruses into humans. We can hardly prevent that because there are 8 billion of us humans, and we are intruding on the natural world. We are destroying habitat. We are disrupting ecosystems. And as we do that, we are exposing ourselves to those hundreds of thousands or millions of viruses that live in those rich ecosystems. It's our actions and not the actions of viruses that cause new viral pandemics. We disrupt ecosystems. We expose ourselves to the viruses carried by wild animals as we destroy those ecosystems. That gives the viruses an opportunity to get into us. As long as we continue doing that, there will be further spillovers and there will be outbreaks. There will be those cases of a dozen or 2 dozen or 3 dozen people suffering a peculiar new disease, some of them dying in some remote place. But if we do what we can do using our brilliant science and our strong public health measures, if we put them in place, then we can prevent future outbreaks from becoming epidemics and pandemics. It'll take surveillance. It'll take the development of international systems of coordination, sharing information, international systems of surveillance, international systems of developing capacity. Again, as Dr. Tedros said, we need to train scientists and public health officials in every country on the planet, local people, bright students who can go into fields of science, biology, infectious disease, medicine, medical research, public health. We need to train them in all the countries of the world and connect them with one another with international agreements to react to these dangerous outbreaks when they occur, to prevent them from becoming epidemics and then pandemics. We must get in front of these threats when they happen. So those are some of the certainties and the uncertainties. Now I come back to those 2 questions that framed this whole thing. First of all, why were we so unprepared to deal with COVID-19? And secondly, how can we be better prepared? First of all, I believe we were unprepared for this one, not because science hadn't done its job. Science had done its job, as I told you. And there were scientists in China and colleagues from other countries who were studying coronaviruses that are carried by bats, and they were warning us. They were warning us in scientific articles over the last 15 or 20 years, particularly since the first SARS outbreak back in 2003, a different virus that came out of a bat, spread across the world. It was a coronavirus. Since then, scientists have been studying the coronaviruses that live in bats, and they have been telling us in scientific articles, beware. Another coronavirus could come out of an animal, possibly a bat, and spread across the world. We had those warnings. Public health officials were warning governmental leaders, yes, the scientists are right. This could be very dangerous. We must be prepared for this. So what happened? Well, it takes 4 different communities, 4 different levels to prevent this sort of thing from happening. It takes science. We had science. It takes public health. We had public health. It takes good, foresightful, and caring national leadership, visionary national leadership that is willing to spend considerable money in prevention, in preparedness. And in my country, in particular, we did not have that national leadership. We had terrible national leadership. We had no coordinated plan. We had a man who was denying that this virus was serious. We had the worst of all possible situations, and some other countries suffered from a lack of good national leadership too. Leaders who were only concerned about whether the pandemic might happen between now and the next election. And when the scientists and the public health people couldn't tell them for sure that this event will happen before the next election, then they dismissed it. They weren't concerned about it because they were concerned only with their own careers. Fourth, we need community participation, community understanding, community buy-in. We need the public to be ready to trust science and trust public health. And that was not the case in many countries around the world. Regular people, ordinary people, did not take this seriously enough, did not obey the public health advisories of social distancing and wearing masks and the other non-pharmaceutical, non-drug, non-vaccine, non-therapeutic methods of containing this. The simple non-pharmaceutical methods, they were not followed adequately in my country. They were not followed adequately in a number of countries. So, because of those two failures, failure of national leadership and failure of communities to buy in sufficiently, we have this pandemic. How can we be better prepared next time? We will have the science, but we must support the science. We must put money and trust into science. We must train young scientists, not just in our own countries, but all over the world. We must train young public health officers, not just in our own countries, but around the world. We must support the international organizations, such as the World Health Organization and others, that perform the service of connecting scientists, public health officials, and national leaders with one another and responding, coordinating response to an outbreak when it occurs in one country. And finally, we must educate the public, young people and all people, better to understand the real, genuine threat of pandemics, the inevitability that there will be future pandemic threats, but the understanding that those pandemic threats can be controlled, they can be limited, they can be contained as mere outbreaks if we do what's necessary, if we trust science, we educate our young people in science, we educate the public with good, transparent information from our leaders and through our news media so that people understand this is a serious problem. It will recur, but we can deal with it. Viruses are ingenious, particularly viruses that can evolve the way a coronavirus can evolve. As I said, they don't run, they don't fly, they don't swim, they don't crawl, they ride, but they also evolve, and they can evolve quickly. So viruses are adaptable, but we humans are smart. We're smarter than viruses. And at the end of the day, that's the good news. That is what can protect us and can save us from another event like this in the future. And I strongly hope and I believe that we will be smart enough to take these measures and protect ourselves against a recurrence of this once COVID-19 is over. So again, I am very grateful. Paloma, thank you. Muchas gracias. Thank you to Congreso Futuro. I am honored to be able to talk with you today. And my friends, I wish you well. Stay safe. Stay sane. Chile is a great country, and I will be very glad when I can come back and visit you again.